So let's come back and start solving numericals which are based on limiting reagent. Fine. So we've already seen what actually is a limiting reagent. The reactant which is consumed the most is a limiting reagent, isn't it? Right. So let's read this question and see how to do the numerical. Dinitrogen and dihydrogen react. It means nitrogen and hydrogen react with each other to produce ammonia according to the following chemical reaction. Fine. Calculate the mass of ammonia produced if 2 into 10 to the 3 dinitrogen reacts with 1 into 10 to the 3 grams of dihydrogen. Okay, they have asked us to find the mass of ammonia when so much of nitrogen, so much of hydrogen reacts. Done. Second question, will any of these reactants remain unreacted? I need to find that also. Next I said, if yes, which one and what would be its mass? Fine. So they've given us the concept, they've given us the balanced stoichiometric or the balanced reaction in the equation. Let's start. Suppose when I have to solve this question, first of all try to write the equation which is given. N2 gaseous state plus 3H2 which is in the gaseous state gives 2 ammonia gaseous state. Right. So nitrogen 1 mole, isn't it? This is 1 mole. Hydrogen how many? Here according to the equation 3 moles, balanced reaction. Then here this is 2 moles. Fine. So 1 mole of nitrogen is how much? 28 grams. Normally nitrogen mass is 14, for 2 nitrogens 28 grams. Hydrogen when I have to take isn't 3 to the 6, isn't it? Right. So 1 is 1.008, so 6 grams. This is 6 grams. Then after that ammonia when I have to calculate, it comes to 2 moles means 34 grams. This is over, isn't it? Yes. So now what is the concept? 28 grams react with 6 grams of hydrogen. So 1 gram reacts with how much? Yes, that is what you should always start with the basic thing. So let us do what I'm trying to explain. So just write 28 grams of nitrogen reacts with 6 grams of hydrogen. Okay, yes. So now 1 gram of nitrogen reacts with 1 gram of nitrogen reacts with how much? Means cross multiply 1 into 6 divided by 28 grams. Okay, this right, this is over. Yes. So now what did they ask? They've asked us 2000 grams of nitrogen. That is what they've given, isn't it? Look here. So they've given calculate the mass of ammonia produced if 2 into 10 to the 3. 2 into 10 to the 3 is nothing but 2000 grams of nitrogen, isn't it? So here I've got this for 1 gram. Now see, 2000 grams of nitrogen will react with, so cross multiply this, 2000 into 6 by 28, which comes to 428.57 grams of hydrogen. Done? Yes. Now just see here when I have to see the weight. Now nitrogen is limiting reagent, isn't it? While hydrogen is an excess, isn't it? So nitrogen limits the amount of ammonia produced. So that is what is the limiting reagent. Let us see. Let us come back and finish up and then come back to the equation. Now 28 grams of nitrogen produces how much? 34 grams of ammonia. Yes, so 1 gram of nitrogen produces how much? 34 by 28 grams of ammonia. Correct? Yes. So 2000 grams, because they've asked us to find for 2000 grams of nitrogen will produce how much? 34 by 28 into 2000, which comes to 2428.57 grams. Okay, this is of ammonia. I found for ammonia, right? So next, this is the first one. What did they ask in the next one? Will any of these 2 reactants remain unaffected? So hydrogen is an excess, isn't it? When I have calculated, right? Hydrogen here is an excess. I've got 428.57 grams of hydrogen. So hydrogen is excess, so it will remain unreacted. This part remains unreacted. So the second answer would be, yes, when you write hydrogen is in excess. Hydrogen is in excess and it will remain unaffected. Remain unaffected because it is an excess. Whichever is consumed more is the limiting reagent, that is nitrogen, remains unaffected. Fine. Now after that, amount of hydrogen remained. How much is the amount of nitrogen? I got 428, isn't it? So that how much hydrogen I can here only I write the third question. I'm solving it here. Amount remained unaffected. It is nothing but 1000 minus 428.57, which comes to 571.43 grams. That's it. Fine. So simple question. Basically, we are trying to write the stoichiometric equation. Then you are showing one after other, which is related to what? 28 grams. Normally 28 grams. That is 1 mole contains 6 grams of hydrogen. Then you started relating to 1 gram. Then you got finally weight of hydrogen. Then out of weight of hydrogen, I can easily say whichever is maximum whichever is maximum consumed is limiting reagent, whichever is left out it remains unaffected. So next 28 grams are calculated, I got this answer, right? So let's come back and see the next question on limiting reagent, which is your NCERT question. Fine. Yes. So now calculate the amount of carbon dioxide that could be produced when 1 mole of carbon is burnt in air. 1 mole of carbon is burnt in 16 grams of oxygen. 2 moles of carbon are burnt in 16 grams of dioxygen. Okay, right. So they've given this question. Let's start how to do this. So basically, when such questions are given to you, so what should you remember? 1 mole. So first of all, your mole concept should be clear regarding this. 1 mole of carbon is burnt in air, correct? Yes. So first of all, let us write the reaction for this. Now I have to write the reaction. Carbon solid combines with oxygen gas to form carbon dioxide, isn't it? Yes. So here 1 mole of carbon, this is 1 mole, oxygen 1 mole, here carbon dioxide 1 mole. So 1 mole of oxygen is now, what is this? 32 grams. Right, 1 mole of carbon dioxide means 44 grams, isn't it? Now equation, first let us go with first one. 1 mole of carbon is burnt, means 1 mole of carbon will burn, how much will it give? 44 grams, isn't it? So simple, the first answer is 44 grams. 1 mole gives us 44 grams. So let us write 1 mole gives 44 grams. That's all. Second, this is your part 1. So the second question, 1 mole of carbon is burnt in 16 grams of dioxygen, right? That means normally 1 mole requires how much? 32 grams for a reaction to occur. But now what do we have? We have 16 grams, right? So what will happen? So the amount of carbon dioxide produced by 16 grams. When 32 grams, when 1 mole, that is your rather if I have to say, when 1 mole you require 32 grams. For 16 grams, how much do you require carbon, or how much 1 mole of carbon? That means yes, the amount of carbon dioxide, rather if I have to see, the amount of carbon dioxide produced by 16 grams, and this has become half the amount of carbon dioxide produced. How much will this become? This also will become 22 grams. So here they've given 1 mole. This is what. Now tell me which is the limiting reagent. Now oxygen is the limiting reagent because it is consumed most. Yes. So oxygen is the limiting reagent. That is the thing. Next one. 2 moles of carbon are burnt in 16 grams of dioxygen. So 2 moles are burned. Again, what is happening here? 2 moles are burned. So basically, when I have to see this thing, right? So let us come back. 1 mole of carbon, if I have to say 32 grams of oxygen reacted to give 44 grams of carbon dioxide. Now in the second step, what did they say? This has become 16 grams. And how much will this become? This will become 22 grams. Right? Now, in the third case, what did they say? They said in this case, oxygen, they said 16 grams will react with only how much? Like 2 moles of, they said 2 moles of carbon are burnt in 16 grams. Again, they said 2 moles of carbon. Now here it is 1 mole. Now they said 2 moles of carbon will burn with 16 grams, they said. Fine. So in this case again, what will happen? Which is the limiting reagent? Fine. So here oxygen is a limiting reagent. Why? It is consumed the most, isn't it? So 16 grams can react with how much? 0.5 mole of the carbon only. But how much? This is 22 grams, right? So in the last case, remember again, in this case again, oxygen is a limiting reagent, right? So 16 grams of oxygen can react with 0.5 mole of carbon only to produce, because this has also become half, isn't it? Yes. So 0.5 mole of carbon to produce 22 grams. So this is how you're going to do. So careful, such things you should just analyze. If this becomes half, this also becomes half, and the one which is consumed is the most or it is a limiting reagent. Right. Let us see the next question. When I have to see the next question, right? In a reaction, A plus B2 gives AB2. Identify the limiting reagent if any of the in any of the following reactions. 300 atoms of A plus 200 molecules of B. Okay, 2 moles of A plus 3 moles of B. Next, 100 atoms of A and 100 molecules of B. Next, 5 moles of A and 2.5 moles of B. Next, 2.5 moles of A plus 5 moles of B. Okay, when such question is given to you, right? So first of all, you need to just see, okay, like as I said, you should have the concept of your number of moles, number of molecules. Yes, so if your concept is clear regarding that, then you can easily solve such questions. Let's see the first question. What did they say? 300 atoms of A plus 200 molecules of B. Fine. So what is the reaction? A plus B2 gives AB2. Fine. Now let us first start solving. In this case, A plus B2 gives me AB2. Now according to the first reaction, what do they say about reaction? One atom of A reacts with one molecule. This is molecule, isn't it? One molecule of B, right? So 200 atoms of A will react with 200 molecules of B. Yes or no? Right? So in this case, B is a limiting reagent. Why? As this is in excess. Identify the limiting reagent. Once again, let us come back. This, according to this, one atom reacts with one molecule of B. Fine. So if they say 300 atoms, rather let us take 300 atoms of A and 200 molecules of B. Fine. So 300 atoms of A, right, will react with 200 molecules of B. So in this case, which is consumed more, or which is more, or which is maximum? 300 A is more and 200 B is less, isn't it? So in case 1, this is your first case. Case 1, B is a limiting reagent. That is case 1. Fine. Let us go to the next part. Fine. 2 moles of A and 3 moles of B. Now let's again come back. 1 mole of A reacts with 1 mole of B. 2 moles of A will react with 2 moles of B, according to this, isn't it? Yes. So now in both the cases, which is this one, 2 moles of A will react with 3 moles of B, this set. So which is consumed more? A. So in this case too, A is a limiting reagent, according to this. Now in the third case, when I have to see 100 atoms of A, 100 molecules of B, both are same, isn't it? There is no limiting reagent in the third case. Nothing, no change at all. Yes, let us write the fourth one. 5 moles of A and 2.5 moles of B, right? So 2.5 moles of B requires only how much? Basically 2.5 moles of A to react. Fine. So now as I see directly, I can see, isn't it, which is consumed more in both of these? B is consumed more. So B is a limiting reagent in this case. Whichever is consumed more is limiting reagent. Simple. Fifth one, 2.5 moles of A and 5 moles of B, they said. Fine. So here again just see which is consumed more in both the cases. 2.5 is consumed more, right? So here in the last case, A is a limiting reagent. That's it. This is how we are going to do the limiting reagent questions. Fine. So let's come back and see one more question, limiting reagent. So here, what do they give us? 500 centimeter cube of 0.200 molar NaCl is added to 100 centimeter cube of 0.500 molar AgNO3 solution, resulting in the formation of white PPT. White PPT, which is insoluble AgCl. Okay. How many moles and how many grams of AgCl are formed? Which is the limiting reagent? How many moles and how many this one are formed, and which is the limiting reagent, they said. Okay, fine. So basically, when such question is given to you, try to write the formula first. What is that? What did they say? AgNO3 reacts with NaCl. Silver nitrate reacts with NaCl. It gives AgCl and NaNO3. What do you get? Silver chloride plus NaNO3. Number of NaCl number of moles of NaCl in 500 centimeter cube. They're given here. See, number 500 centimeter. Number of moles of NaCl in 500 centimeter cube. What is 500 centimeter cube? Nothing but 0.5 liter, isn't it? Yes, of 0.200 molar of NaCl. Fine. Once again, let us write what I'm trying to explain. Number. Right. So let's come back and do the numerical. As I said, the numerical, let us read it once again. Fine, I've done a part of the earlier video. Maybe I'll just redo it again for you all. Right. So what did they give us? Basically, they've given us 500 centimeter cube of. Let us type this off and start with the numerical. Before going into that, what should we remember? What is limiting reagent? Limiting reagent is something or the reactant which is mostly consumed. Means the quantity of the reactant whichever is less, that means it is consumed more, and that will be the limiting reagent. Once again, if one of the reactant is A and one of the reactant is B, right? Suppose after the reaction is complete, if the reactant A is 5 grams and if the reactant B is 3 grams, that means out of A and B, which is more consumed? B is more consumed. That means B will be the limiting reagent. So the reagent or the reactant which is consumed the most is a limiting reagent. Then let us read the question now. 500 centimeter cube of 0.200 molar NaCl solution is added to 100 centimeter cube of 0.500 molar AgNO3 solution, resulting in the formation of a white PPT of insoluble AgCl. Okay, how many moles and how many grams of AgCl are formed? What is the limiting reagent? So basically, what they give us? They've given us silver nitrate. Okay, it reacts with NaCl. Done, and it forms a white PPT of AgCl. Yes, this is your white PPT, and in this white PPT along with that NaNO3 is formed according to this reaction. Now what should I find out? I need to find out for AgCl, I need to find the number of moles. Along with that, I need to find the mass also in grams. This is my task now. So first of all, when such question is given, you try it given. First of all, they've given us 0.200 molar. Okay, molar means nothing but molarity, isn't it? Yes. First, try to find out among these two which is the limiting reagent, because they have two things given. See here, how many moles and how many grams of AgCl. This is what is there. What is the limiting reagent? I need to find one limiting reagent. I need to find the moles. I need to find the grams. So let us start with finding out the moles. So first of all, divide the page into 2 equal halves. Now let us divide this page. The first one, we'll calculate moles of NaCl first. Then in the second case, we'll calculate moles of AgNO3. Moles of AgNO3. Done. Now how much did they give me? They've given 500 centimeter cube of 0.2 molar NaCl. So here they've given 500 centimeter cube. What is 500 centimeter cube? It is nothing but 0.5 liters, isn't it? Of how much? Of 0.200 molar. Now let us write for AgCl. They added to 100 centimeter cube of 0.5 molar AgCl. So let us write here 100 centimeter cube. That means what is 100 centimeter cube? It is nothing but 0.1 liter, isn't it? Of how much? 0.500 molar. This is over. Now what should I calculate? I need to calculate the moles of both. Once I calculate the moles of both, I can tell whichever is mostly consumed, that will be the limiting reagent. Now come back. Here, according to molarity, it is molar, isn't it? Molar is nothing but molarity. Molarity is equal to number of moles by volume of the solution in liters, isn't it? Here also same, molarity is equal to number of moles by volume of the solution in liters. Let us turn the page and do the sum. Fine, this is what you have written. Now here in this case, number of moles. What is this? Now I need to find N. N is equal to molarity into volume of the solution in liters. Both the case is the same. N is equal to molarity into volume of the solution in liters. Hope this is clear. Now how much is the molarity which they've given us? They've given us 0.200, isn't it? That is the molarity which they've given. Just turn back and see. They said 0.2 molar solution. That thing but molarity, isn't it? Substitute that here. N is equal to 0.200. What was the volume? It is 0.5 liters. In this case, we have got 0.500 into 0.1 molar. Now in value, here when I multiply, I get 0.1 mole. Okay, this is for what? This is for NaCl, and when I multiply here, I get 0.05 mole. This is for what? This is for nothing but your AgNO3. Okay, now compare. I need to find the limiting reagent. Now directly see here, 0.1 mole is NaCl, 0.0. Okay, well, let us write that reaction once again. NaCl plus AgNO3 gives me AgCl plus NaNO3. Okay, now how much was this one? NaCl is how much? 0.1 mole. How much is AgNO3? 0.05 moles. Now compare. This is 0.1, this is 0.05. Which is more consumed among these two? This is more consumed. AgNO3 is more consumed. So here the limiting reagent here is AgNO3. Why? Because it is more, or it is consumed more or more consumed? More consumed. It is more used up. It consumed means it is used up. Yes? Fine. So this is over. The first part is over. I need to do the second one. What should I do in the second question? They've asked me to find out the moles in grams of AgCl. So when I have to do that, moles in grams, I'm solving the second part of it. Let us make it line now. Yes. So when I have to solve the second one, they've asked me moles in this. So we have again the same formula. What is that? Molarity is equal to N by V. Okay, N is equal to molarity into liters. Easily you can do this, isn't it? Yes, fine. So here a number of moles also I can find from here, N into M. Yes, done. How much is the number of moles of, okay, molarity of this, right? How much did I get? I've got like 0.05 AgCl, isn't it? Yes, so 0.05. 0.05. How much is this one of this one of that? The thing, what do you say, mass of this, it is 143.5 grams. So when I multiply, okay, what is this one here? I need to find mass, isn't it? Okay, mass is equal to N by V. Okay, this is done correctly. It is for 7.2 grams of AgCl. This is how you find. Now next one, when I have to see the mass, molar mass of AgCl. Okay, molar 143.5 is molar mass of AgCl, isn't it? Yes, fine. How did I come, ma'am? How did you get this? Let me see. See, 1 mole of NaCl combines with 1 mole of AgNO3, isn't it? The same thing to form 1 mole of AgCl. Come back again. 0.05 moles of NaCl combines with 0.05 moles of AgCl to form 0.05 moles of this one. What do you say? AgCl. That's why I've taken 0.05 here in this case. Molarity I've taken as 0.05. That is the reason I've added. Multiply this. So final answer is 7.2 grams. Fine. Hope this is clear. I've clearly explained step by step reaction. Let us come back and do the next question. Limiting how many moles? Fine. So here we have magnesium sulfide question. So this is also an interesting question, but the only thing is you need to remember how to do this concept. Let us read. How much magnesium sulfide can be obtained from 2 grams magnesium and 2 grams sulfur by the reaction magnesium sulfide MgS. There is one reaction given here. Okay, which is a limiting reagent. Calculate the amount of one of the reactants which remains unaffected. So once I calculate limiting reagent, the leftover is unreacted, isn't it? Let's see. First of all, let us write the reaction. What is this? Magnesium. I'm copying the same reaction here. Magnesium plus sulfur gives me magnesium sulfide. Right. So what did they say? 2 grams of magnesium and 2 grams of sulfur, they said. So let us find the number of moles first of all. So here number of moles for both we'll calculate. Number of moles in terms of magnesium and number of moles in terms of sulfur. So N is equal to, okay, 2 grams means what? So earlier 2 grams of magnesium is how much? Yes, according to this 2 grams of magnesium is nothing but 200 divided by molecular weight 24.3. It comes to 0.0824 moles. Okay, now for sulfur, how much is this? Again 2 grams. 200 by how much is the sulfur weight? 32. It is equal to 0.064 0.0624 moles. Now see in this case it's 0.0624 moles. In this case 0.0824 moles. Both are there. Now in both the cases, which is less or which is more consumed, which is more consumed here? This is 0.08 of magnesium and this is 0.06 of magnesium. So sulfur is more consumed, isn't it, in this case, right? So what is the limiting reagent? Whichever is consumed more, that will be the limiting reagent. Once again, the one which is consumed more is the limiting reagent. So here sulfur is consumed more compared to this with a given weight 2 grams converted, and according to sulfur. So sulfur is a limiting reagent. Sulfur is a limiting reagent. This is over. First thing. Now what should I find? I need to calculate the amount. This is part is over. We'll come here. Calculate the amount of one of the reactants which remains unreacted. So which is remaining unreacted? That means whichever is excess. That is magnesium. Now we'll see. Sulfur is so much. Magnesium is so much. So we'll calculate both. Let us turn the page. We'll calculate both the cases. What should I calculate now? I need to calculate moles of magnesium, and I'll also calculate mass of magnesium. Mass of magnesium left unreacted. Both we will calculate. So moles of magnesium, mass of magnesium. So moles of magnesium is limit 0.084. What that was thus. The leftover this one sulfur I'll take out 0.0624. I'll take out. What do you get? 0.0200 moles of magnesium is left. Okay, and this is what is left. Now mass of magnesium, how do I do? Normally N is equal to W by M, isn't it? So or if I have to do the other way, this is equal to N by volume. Okay, let us come from here. N, what is N? N is nothing but weight by molecular weight. This is what I have written here, right? Okay, N by fine into 1 by V. Okay. Now what do I require? I require the mass. Take out W. W is equal to cross multiply N into M, because I need mass. How much is number of moles of magnesium? I have got here W is equal to 0.0200 into how much is the molar mass of magnesium? This is nothing but 24 grams. Yes. So when I multiply, I get an answer of 0.486 grams of magnesium. Okay, this is what your answer is. Fine. So I have got moles, I have got mass, right? Then I have got even the limiting reagent, right? This is how you're going to do. Hope this is clear with the sum. Let us go back to the next sum of limiting reagent. Fine. So here they've given us, let's read the question. 50 kg of nitrogen, it seems. Well, 50 kg of nitrogen and 10 kg of hydrogen are mixed to produce ammonia. Okay, as soon as such question is given, just try to write the reaction in keep. Stoichiometric reaction. What is stoichiometric? Balanced reaction in keep. What is this? Nitrogen gaseous state, it combines with hydrogen gaseous state to form ammonia NH3 gaseous state. Now here hydrogen is 3. So here hydrogen is 2. Here nitrogen is 2. So I'll put 2. Now 3 2s are 6 hydrogens. Now balance here. 3 2s are 6. Now balanced. Now let's read. Now this reaction mixed to produce ammonia itself. Calculate the ammonia formed. I need to calculate the ammonia form. That is first. I need to identify the limiting reagent in the production of ammonia in this situation. Fine. So let us calculate separately. Let us start solving. Let us take this part for nitrogen. Let us take this part for hydrogen. Fine. I need to calculate what? Limiting reagent in terms of moles. Fine. So what is number of moles equal to? Like basically if I have to write this one, number of moles is equal to weight by molecular weight, isn't it? Now see, what am I going to do? Now I need to, both the cases I'll calculate moles, and whichever is consumed more, that will be the limiting reagent. Now see, how much did they give us? They have given us 50 kg and 10 kg of hydrogen. I need to convert it into moles. Now I'll be using dimension analysis. How is this done? First of all, 50 kg, right? Weight by molecular weight, isn't it? Number of moles. So 50 kg. What is the mass of nitrogen? It is nothing. This for nitrogen, it is nothing but grams. Now to cancel this kg, I am going to divide by 1 kg. So this kg and this kg gets cancelled. Now 1 kg is how many grams? It is nothing but 1000 grams. So cancel this grams and this grams into. Now here you multiply with 1 mole. Now see here. This and this gets cancelled. This and this get cancelled. The final answer which I get, I'll get in 1 mole. Isn't it? So when I solve this, I get an answer of 17.86 into 10 raised to 2 moles. The same case applies here. 10 kg hydrogen. So 10 kg hydrogen into, to cancel this out, I am going to multiply with 1 kg. gone, cancelled. Number of moles is weight by molecular weight. What is the weight of hydrogen? Just 2 grams. Okay, yes. So now this is grams. Now 1 kg is equal to how much? 1000 grams. This gram gets cancelled and multiplied with 1 mole. Now kg got cancelled, gram got cancelled. What am I left with? Moles. Now multiply n is equal to 4.96 into 10 raised to the power of 3 moles. This is what is answer. Now when I compare both the answers, now see which is more consumed here. 4.96 is more consumed, right? Hydrogen is more consumed. This is 17.86 of nitrogen is left out, but here hydrogen is consumed more, 4.96. So what will be the limiting reagent here? So hydrogen is a limiting reagent. Let us write that question. Hydrogen is a limiting reagent. Why? It is consumed more. Limiting reagent as it is consumed more. It is consumed more. This is what is consumed more. Fine. Now next one. What should I find out? I need to find out the amount of this one also, isn't it? The amount of ammonia also. Let's see. Now accordingly, I'm doing the second one. According to the equation, yes, nitrogen, how much nitrogen? Nitrogen, how much it react? It will react with N2 plus 3 H2, isn't it? It will react with 3 hydrogens to form 2 NH3, isn't it? Yes. So how much normal nitrogen? How much did I get? I got nitrogen mass is 17.86. And 17.86 into 10 to the power of 2 moles of nitrogen. Will react with 3 into 17.86 into 10 raised to the power of 2 of hydrogen. This is what is the concept, because it is 3, isn't it? Now how much do I get? I get an answer of 5.36 into 10 raised to the power of 3 moles. Fine, this is how I got. Fine, so I got so much of nitrogen unreacted. I also calculated the limiting reagent. So this is the procedure to do the limiting reagent numericals. Simple, nothing much complicated in this. See, the reactant which is consumed more is the limiting reagent. Yes.